then we move on to extract time-based features. So we have df clean hours equal to df.clean.time divided by 60 as type in all the way to df.clean minute is equal to df.time divided by module 60.as type. Basically what this block of code does, it basically converts the time into like an hour and a minute component. Then we move on to df.get time period equals to hour all the way till return night. Basically what this block of code is it creates like a time period category. So basically if 5 is less than or greater than hour, which is less than 12, it assigns it to like morning. And then if 12 is less than or equal to hour, which is less than 7, it's assigned it to afternoon, and so on to like evening to for this one. And if it's not all of these, it's being assigned to night. Basically this is done as different time periods have like different delay patterns due to like air traffic congestions, weather conditions, and like passenger volume. So yeah, then we move on to df.clean. Time period is equal to df.clean hour.apply get time period. Well, basically what this block of code does, it creates like a categorical feature of like time period that basically groups like similar flight times together. Then we move on to df.clean date type is equal to df.clean day of the week apply lambda x. With these parameters over here, well, basically what this block of code does, it creates like a data type like such as like weekend and weekdays, where basically 1 to 5 is being assigned as like weekend, and the weekdays are being assigned from like 6 to 7. So yeah. Next we print out the time-based features created, which are like the hours, the time periods, and the data types over here, and here are like the outputs. So now the hour ranges from 0 to 23, the time periods are from night, morning, afternoon to evening, and the data types are the weekdays and weekend. Next, we move on to visualizing time-based patterns. So plt.figure is equal to fig size 15 and 10. Basically creates a figure size of like 15 times 10 dimension. Then here we basically plot like the delay rate by hour of the day by using hourly delay is equal to df.clean.group by hour and delay mean over here. And then we plot it with these parameters, and we title it, and then we label the x and y variables. Here we plot the delay rate by the day of the week over here, and then here we plot the delay rate by the time period over here, and here's the code for the delay rate by the airline, and then the flight length versus the delay over here, and then the weekday versus the weekend, and then we plotted all them together. So here's our graph. So here we have like, so in like earlier morning, there isn't as much of like a high delay rate, as there's not that much demand, as compared to like later on throughout the day where the delay rate increases as there are more passengers. Then we have the delay rate by the day of the week. So the weekdays are like have like a high delay rate as compared to the weekends. Then we have the delay rate by the time period. So like evening and afternoons have high delay rate as compared to like morning and night. Then we have the delay rate by airlines. So WN has like the highest delay rate all the way down to like YV, which has like the lowest delay rate. Then we have the box plot for the flight length distribution delay. So we have the no delay over here with like the box plot and the outliers, and then the delay box plot with its outliers. And then we have the delay rate by the weekdays versus the weekend. As I told before, the weekdays have like a higher delay rate as compared to like the weekends. So yeah.